Hello guys, I hope you will be fine, and today I'm gonna make you learn how to implement the 7 logic gates in PROTEUS. So first I'm going to choose the exclusive NOR gate whose IC number is 4077. So I'm just choosing the LED to show the outputs. You can also choose the logic probes, and then after that I'm choosing the resistors. I will connect these resistors to the input terminals and then I will ground it. These resistors are connected with the input terminals in order to remove the static charges of the back voltage or other stuff like that. Now you can use the push buttons. You can also use the logic toggles. So I'm using the push button and now connecting the power source with each button. You can also connect the power source with the 2 buttons that are connected in parallel. So mark the value of 5 volt in the power source checkbox. So now I will tilt the resistor in order to make a good looking circuit like this and this. So connecting this resistor with this terminal and this terminal, and then ground it and this as well. So as you can see, the exclusive NOR gate truth table, the output will be at high or 1 logic state when both the input is 00 or 11. So here is the simulation. You can see that the LED turns on when both the buttons are on or both the buttons are off. Now I'm going to replace the exclusive NOR gate with exclusive OR gate without replacing the circuit. Whose IC number is given above. I have written that. So here is the truth table. You can see that the output will be 1 when both the inputs are a different logic state like 0 and 1. So the simulation is continuing. You can see that the LED turns on when both the buttons are at different logic state, that is 0 or 1. Now I'm going to replace this gate with OR gate. It's quite simpler one. I've used only single power source and connected the buttons in parallel as I discussed earlier. So now connect this. Here is the truth table. You can see that the logic state will be 0 when both the inputs are at 0. It will be 1 when only one logic state will be at 1. So let's start simulation. Here you can see that the LED will turn off only in the situation when both the input buttons are at 0 logic state or they are open. So let's move on to the NOR gate whose IC number is 7402. Here it is. You can see the truth table. When both the inputs are at 0 logic state, the output will be 1 only in this situation. Here we go. Let's start the simulation. You can see that both the inputs are at 0 logic state, so the LED is turned on. Now moving towards the AND gate whose IC number is 7402. So connecting it with the circuit like this without changing the circuit. It's quite very easy to implement. So here is the truth table. It has the 1 logic output if and only if both A and B button are at high logic state. Here we go. Let's start the simulation and then see that this is the LED is turned on only when both the buttons are closed. And then we move on to the Nand gate. Its IC is 7400 as explained. Here it is. The output is 0 only in the situation where both the inputs are at 1 logic state. So as you can see that the LED is turned on and off only in the situation where both the inputs are at one logic state. So now moving on towards the NOT gate. Its IC number is 7404. Actually I'm telling the IC number because it has also the PCB simulation model. You can also make its PCB layout. So NOT gate has a truth table like this one. When the input is 0, output is 1, and when the input is 1, the output will be 0. So here it is. I hope that you will really like this video. So don't forget to subscribe and like it.